Welcome to qnawire.
Hi, so over here we're going to have the reaction of precipitation of silver sulfate coming from a combination of two different solutions. So first of all, we're going to get 5 milliliters of 0.18 molar silver nitrate, so that is AgNO3, that we're going to add with 4.6 milliliters of 0.5 molar sodium sulfate, which looks like this. So the reaction that we are actually looking at is silver nitrate plus sodium sulfate is going to generate sodium nitrate plus silver sulfate. But the sulfate, it is going to be as a solution. How do we balance this equation? We simply need to introduce a 2 over here, and we are good to go with another 2 in this point. Okay, so now what we need to know first is what is going to be my limiting reagent. So, in order to know the amount of mole of silver nitrate that I'm going to have in solution, let's remember the definition for molarity, that is amount of mole divided by the volume in liters. So, I'm going to have the amount of mole equal to volume times molarity. So, 5 times 10 to the minus 3 liters, because we have only 5 milliliters, times 0.18 molar. Next up, we're going to have sodium sulfate. Same procedure, 4.6 times 10 to the minus 3 liters times my concentration, 0.5 molar. And the result over here, we are going to get 2.3 times 10 to the minus 3 mole of sodium sulfate. And over here, we're going to get 9 times 10 to the minus 4 of silver nitrate. Now, in order to know which one is going to be the limiting reagent, this guy can react with, we're going to use the stoichiometric relationships. We know that 2 mole of silver nitrate corresponds to 1 mole of sodium sulfate. So this guy can react with up to 1.8 times 10 to the minus 3 mole. This quantity is smaller than the initial amount of moles that I have of sodium sulfate, so limiting reagent will be silver nitrate. Now that I know which one is the limiting reagent, what I can go ahead is do the calculation of how much amount of mole of sulfate it is going to be free. The way to do it is we're going to start with 9 times 10 to the minus 4 mole of my limiting reagent, silver nitrate. We're going to use the stoichiometric relationships. 2 moles of silver nitrate correspond to 1 mole of sodium sulfate. 1 mole of sodium sulfate corresponds to 1 mole of sulfate. And we're going to get, sorry, over here, just a small correction. This should be 4.5 times 10 to the minus 4. So an even smaller amount. 4.5 times 10 to the minus 4. Okay. So this is going to be the other result will be the same, 4.5 times 10 to the minus 4 mole of sulfate that is going to react. We can subtract that to the initial amount. So 2.3 times 10 to the minus 3 mole of SO4 to minus that I had initially, minus 4.5 times 10 to the minus 4 mole of sulfate, gives us 1.85 times 10 to the minus 3 mole. That is going to be left in solution. Now we simply need to divide this by the total volume. So concentration of sulfate will be 1.85 times 10 to the minus 3 mole divided by, I added a total of 9.6 milliliters of solution. So 9.6 times 10 to the minus 3 liters, giving us a 0.193. 0.193 molar solution of sulfate. Now for part B, we're going to calculate the mass that is going to be produced of the silver sulfate. And the way to do it is, recall that essentially our ionic equation is the following. So the amount of sulfate that reacted is going to be equal to the amount of silver sulfate that is produced. I'm going to take the amount of sulfate that reacted. So 4.5 times 10 to the minus 4 mole of sulfate corresponds to the same relationship. 1 mole of sulfate corresponds to 1 mole of silver sulfate. And next, we're going to employ the molar mass. So 1 mole of silver sulfate has a molecular weight of 311.8 grams per mole. So our final result will be 0.1403 grams of silver sulfate. And that will be all. Thank you very much. Again, sorry for the small correction that I made over here. It's just a division by 2, but everything matches up correctly. Thanks.